Hey kids, it is Monday and you're on your day off here, the 16th of January. I'm just gonna run through a quick review for those of you perhaps that missed a couple days and need some brushing up on chapter 17. So this is the test review problems and the solutions. You probably got those on Friday before we left for school. We do have a test tomorrow, so that's why I'm calling, or actually not calling, that's why I'm putting out this video. So quickly review. These here, the heats of fusion and vaporization, these numbers here are specific to water, and so make sure that if it is water, that's what we're going to be using, and we'll give you these values so that you know what to use. Don't be afraid to ask, but we will have these values for you. And one thing to add here, the temperature rises, it's obvious that heat's putting into it, but as these plateaus sit here, remember heat is going in, it locks itself into that temperature until the phase is completely gone. So in other words, it's frozen, it's a block of ice, and here it starts to turn to water, and then in between you have water and ice, and until you get to this point, and then it's all liquid or water, and then it's all liquid, 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 and then up here is where it starts to turn to gas, and it's going to stay at 100 degrees even though heat is going in. There's a heat that is being used to try and convert it all from liquid to gas. When it gets to this point here, it's all gas, and this is all steam up here. Just to give you an idea of what this graph looks like, there's going to be some questions that are relevant to this graph and that scenario we just pointed out. Use these, know how to use each one of these constants here, and so that you are familiar with those things. These questions are really important to find boiling point, melting point in terms of vapor pressure. Make sure you know all those things, and it does talk about how boiling point is where we talked about how the vapor pressure, atmospheric pressure must be equal in order to do that. And then and there is a lot of questions relating to these intermolecular forces and how they hold things together better. The stronger the intermolecular forces, the higher the boiling points, and in other words, it's held together tighter. And then we're going to talk about these little air pockets and ice and so forth. These are all great questions, and so make sure you get to those. I'm going to jump to this sheet here. This was the rules and guidelines, and this little link here is super important, and I'll show you why. Here it is. So if you don't know what it is, here it is, boomeria.org/chem textbook, and then this is chapter 17. I went ahead and did 17 for us. So I am going to change the size of this so we can see it all. So just to kind of go over it, it's all about liquids today. It says here, you can read all this. This is from your textbook, so make sure you go through it. It talks about freezing points and melting points, for example, and what those mean, and how they're pretty much the same thing. How a melting point means it's going from a solid to a liquid, and then a freezing point is going from a liquid to a solid. And know all those things, obviously. Vapor equilibrium, there are a lot of questions on this vapor equilibrium, and it does talk about the open and closed container. So it says when a substance is in equilibrium with its vapor, the gaseous phase of the system is said to be saturated with the vapor of that substance. So that's when everything is closed off. Notice it says it's closed container. That was the first day notes. And it says such a situation up here up top above it, such a situation is known as an equilibrium condition. And it says there's a special kind called a dynamic, and it is called a dynamic because molecules are continuously escaping from and returning to the surface. However, the overall result it remains constant. In here, it's dynamic, means that it'll go to gas, return to a liquid, and then it's over and over again. So liquid to gas, gas to liquid, liquid to gas, gas to liquid. It's dynamic. It's constantly moving, and that is a type of equilibrium. One thing that's really important here is Le Chatelier's principle. Know what this is. Know how to tell somebody what it is. It is on the test, so make sure you know that. It is important. This whole thing is on Le Chatelier's. In other words, you stress a system, and then it's going to react, and then the opposite way. So when you add something, it shifts to the right. you take away it, well, I guess it depends on which side you're looking at, and we can go over those tomorrow before the test, but know what this means. All right. Measuring vapor pressure, they talked about measuring, and here's vapor pressure. Melting points, again, sublimation, know what that is, going from a solid to a gas, skipping the liquid phase. Boiling point, we discussed on what it means when vapor pressure equals at the atmospheric pressure, and we boiled at room temperature to show that. Oh, this graph is very important. Know how to read this graph, and then it says here, so if it gives you a substance and it tells you that the vapor pressure, or excuse me, the atmospheric pressure has changed, what's the new boiling point? And it'll ask you those questions. That was from the homework the first night. Let me see. Moving on down, phase diagrams, really important. These phase diagrams are super important. And then where the test falls into it, there are questions on the test where you would see where likelihood of a solid, where would you see a solid and lower temperatures. And notice that the solids it will exist here, and this pressure is increasing, so it's higher pressure, right? As the pressure increases, things become more organized. We said that the other day. And as the pressure decreases, then it becomes more disorganized. Now this one here, this is I believe hydrogen, so it's very, very cold, and it has to be very, very small pressure in order to be a vapor. And so that's really important that you understand what these phase diagrams mean, and just like I said, where the pressure and the temperature fall in with the phase itself. Let me see the energy and the change of state. This is these graphs here. We went over it. We talked about this. Aha. And this is the last piece that we need to discuss. Talked about hydrogen bonding, and it talks about how hydrogen is so strong with oxygen and how it creates that dipole moment. What that means, it really holds together really well. It has a very strong intermolecular force. That's hydrogen and oxygen and water. So now, see how it makes this really nice space, these little gaps here. When you drop the temperature of water down, it starts to increase its density about 4 degrees Celsius. So on the way down to 0 at 4, it starts to decrease, its density, where normally it would be packed in there so tight. It starts to decrease, and we talked about how this solid water or ice floats on its liquid because of these air pockets. And that's what's going on. It's very organized. And it's a very unique situation. That was the graph that we showed where hydrogen and oxygen are very strong and has a high electronegativity, and then it creates this intermolecular force. This was on the last day in notes. Really important. And then it talks about the surface tension a little bit. Not too much of that is on the test. And so you should be okay. Oh, this is a bit about the meniscus of water here on the left and the meniscus of mercury. It's a good idea to read through this. This is really important, so make sure that you kind of get all these things here. You could go into this more on liquids into this PowerPoint. You can go there and review some great things. So again, just review. Make sure that you do cover all these topics. The diagrams are very, very important. And then make sure you know the relationship between intermolecular forces and boiling points and how those play a role. And then when something is volatile, what that means, volatile means that it goes to a gas very easily, where non-volatile tends to stay in the liquid phase. Again, having to do with intermolecular forces. So there we have it, kids. I know that you might be a little bit stressed, but I hope this helps you out. Please review. Please study. Excuse me. I think that you'll do really well if you do those things. Let me know if you have any questions. All right. See you tomorrow.